Let's go over graphing step functions using the function u sub c of t. Now, as a reminder, the definition of this function is it's equal to 0 if your value of t is less than whatever the number c is equal to, and it's 1 if t is either greater than or equal to c. So to visualize this particular function, you choose a number c here. If you are to the left of c and not equal to c, the function is always equal to 0. But at c, it equals 1, and then it's 1 forever going in the other direction. If we look at this function here, it is not defined using this thing, but it is simple enough to graph. It is something different if we're less than 2, between 2 and 5, and then greater than 5. So if we're at 2 and less than 2, it's 0. So I'll graph an open circle here, and moving in this direction, it's always equal to 0. Now, at 2 and up to but not including 5, the function is equal to 1. So I'll draw it like this. And then if we're greater than or equal to 5, this thing is equal to 4. And this is a step function. Now, you can rewrite this function as a sum or difference of things that look like this. Let's go over that process. If you're at 2 and you're less than 2, you want the function to equal 0. So one way you could define this function is f of x is equal to u sub 2 of x, and leave it just like that. So if we're less than and not equal to 2, this function will be 0, which is precisely what we want. And then if you are greater than 2 or even equal to 2, the function is going to equal 1. So from here up to right about here, this function actually is u sub 2 of x. But the issue is there's this other part over here. If it was just this function, it would always be 1 from 2 onward. But the second you get to 5, you don't want it to be 1, you want it to be 3 more, up at 4. What you can do is you can add on 3 times u sub 5 of x. And this will actually give us this function here. The way you determine this is by first starting with the smallest number here, which is u sub 2 of x. And to the left, it's 0, and to the right, it's 1. But you have to incorporate another function where a change happens, in this case is 5. And you can notice that if you're at 1 and you want to get to 4, since this function never goes away, it's always 1 here, you can add 3 more at 5 to bring it up to this thing here. So step functions can be expressed this way. So not as 3 separate parts, but the sum of 2 separate functions. Let's try this out in a couple of examples. In example 1, we'll graph the function f of t, which is the sum of 3 functions, 2 of which are a u sub c type function. The thing to notice is, for this function here and this function here, this value is pi and this value is 2 pi. So if you're less than pi, both of these are 0 and they contribute nothing to the function. It's like they're not even there. So to graph from, let's say, 0 onward, all you have to do is graph sine of t. So the sine function, let's see, it starts at 0, it goes up to 1, and then back down to pi. So I'm going to sketch that in. And I'll put an open circle here at pi, because at pi, well, this is no longer 0, and it's going to add something to this function, potentially. Now, I'll also put this going in the other direction too, so we get something like this. Okay. Now, at pi, this thing is still 0, but what we can do is we can add whatever this is to this function that still exists. So sine of t never actually goes away. It's oscillating forever. But from here and on, you're going to add 2 to it. So if you can visualize it, this is sine of t. It looks like this. It starts at 0, it ends at 0, and its lowest value is 1. This thing is now adding 2 to that function, so all of those points are going to go up 2 places. So this spot here goes up to here, this spot here goes up to here, and the one that is at -1 goes up to +1. So your function between pi and 2 pi looks like this. And the only thing to be careful about is the second you get to 2 pi, now this thing's no longer 0, and it says, okay, well, this isn't 0, that's not 0, but you have to add 3 to whatever the function is here. The sum of these two things is a sine function that oscillates forever in both directions, but now we're adding the number 3 to that. So this spot here was at 2, adding 3 more to it is going to take it up to 5. So it would have been oscillating like this, except it's going to be 3 higher. So here, here, and drop back down to here. So that's this to this and down like that. So here is the function f of t. Let's try a similar problem in example 2. Here, we have f of t as the sum, again, of 3 different pieces, and this is a u sub 3 and a u sub 4. What this means is, if you're less than 3, both of these things are 0, and they contribute nothing into the equation. You're just graphing f of t is equal to t. So that's a line whose slope is 1. So that's this thing here. And you just have to be careful that, well, once you get to 3, I'll put an open circle, because at 3, well, this thing is no longer 0. This is still 0, so I don't have to worry about it. But I have to think about, well, what are these two equations if you combine them together between 3 and 4? I'll do some work off to the side. If you are between 3 and 4 like this, f of t is equal to t plus t minus 6. And the reason for this is, if you're greater than 3, this thing is 1, which is just t minus 6. This is always present, and this thing is 0. So your function, f of t, looks like 2t minus 6. This is a line whose slope is 2. Now, it starts at 3, so if you put a 3 here, that's 6 minus 6, that's 0. So you actually, at 3, have a function that is at 0, like this. Now, if you plug 4 into this function, you get 8 minus 6 is 2. So at 4, it goes up to 2, but I'm going to put an open circle there because technically you're not allowed to use it, so I'll see this thing. And, all right, well, what happens if you're at 4 and greater than 4? So now, this. Okay, in this case, this is equal to 1, this is equal to 1, this is going to be present as well. It'll just be the sum of these 3 functions without u sub 3 or u sub 4. So f of t is t plus t minus 6 minus 2t, which we already know we have 2t minus 6 minus 2t. Therefore, f of t is actually always negative 6, which is here. And that's a horizontal line like this. So here is a graph of this function. And basically you just have to determine where do the changes happen, and then graph the appropriate functions in those 3 separate regions.